All right, let's jump right into this explainer. Today, we're building your absolute ultimate defensive toolkit for doing safe, totally untraceable online research. Whether you're an investigator, a researcher, or really just someone wanting to know how the pros stay hidden online, you absolutely have to understand operational security, or OPSEC. Now, starting from first principles, OPSEC is basically a systematic process. It's how you identify your own sensitive information, assess the specific threats out there that could expose you, and then implement really strict safeguards to protect your identity. So today, we're unpacking the exact tools and techniques that cybersecurity pros, journalists, and intelligence analysts use to shield themselves while they're deep in the trenches of lawful online investigations. Here is our roadmap for today. We've got the power of OSINT, fingerprinting threats, browser isolation, virtual machines, and VPNs and workflow. We're going to construct your OPSEC kind of like a set of nesting Russian dolls, starting with the core ideas, identifying the invisible threats, and then systematically building your defenses outward, layer by layer. Okay, starting with Section 1, the power of OSINT, or gathering intelligence safely. Before we build our shield, we kind of got to know what we're protecting, right? And that is the intelligence gathering process itself. That brings us to open source intelligence, or OSINT. The really crucial point here is that OSINT is completely lawful. It relies entirely on public data. It's heavily used by cybersecurity professionals tracking threats, law enforcement looking at criminal networks, and journalists trying to uncover the truth. But just because data is public definitely doesn't mean gathering it is without risk. If you're investigating a dangerous target, the very last thing you want is for them to start investigating you back. This brilliantly illustrates the rigorous life cycle of OSINT. Notice how it moves so methodically from planning, right into collection, and then to processing and analysis. It's a highly structured cycle. And this process requires absolute, rock-solid operational security, especially during that collection phase. You have to prevent your targets from even getting a whiff that they're being watched. So why does this matter so much? Well, if your digital footprint leaks during collection, you don't just risk tipping off a target. You can literally compromise your entire investigation. Picture this. You've got an expert in computer forensics taking the stand in a trial, right? And then their evidence gets thrown out entirely just because their personal browser tabs or their home IP address cross-contaminated the screen captures. It's a nightmare scenario. The purity of your investigative environment is absolutely everything. Which brings us to Section 2, fingerprinting threats, the invisible trail. To defend ourselves against these threats, we really need to shatter a huge myth right now. Simply hitting clear history or opening an incognito window? Yeah, that does absolutely nothing to keep you safe from modern tracking. We have to understand how websites actually see you. And they don't just look at your IP address anymore. They look at your screen resolution, your CPU type, your exact operating system version, even the specific fonts you have installed. Trackers actually combine all these seemingly random generic hardware details to create a unique mathematical hash. And that hash, it identifies your specific computer among millions of other devices online, tracking your every single click. Let's compare these threats for a second. Traditional cookies are just small text files saved on your machine. You can easily delete them, no big deal. But modern stateless tracking, things like Canvas and HTML5 fingerprinting, that is a whole different beast. Canvas fingerprinting actually forces your browser to draw invisible graphics in the background just to detect the unique rendering properties of your specific graphics card. It's wild. It's incredibly difficult for non-technical users to detect or block, and it works flawlessly even if you've totally disabled traditional cookies. Seriously, if you think you're currently flying under the radar, I highly encourage you to go test it out. Visit a testing site like browserleaks.com. It is honestly shocking to see the sheer amount of unique data your web browser is broadcasting to the public internet at this very moment. Fully understanding this exposure is step number 1 in operational security. All right, let's fix that. Section 3, browser isolation, your very first line of defense. Now that we know the threat of fingerprinting, let's build that first layer of OPSEC defense. We essentially need to put a wall between your personal life and your investigative activities. This starts with browser containers. Think of containers like soundproof rooms built right inside your web browser. If you're logged into a covert social media account inside one container, the cookies and trackers in that specific container cannot hear or interact with your personal browsing in a different container. They are totally 100% separated. So how does this look in a practical daily workflow? Well, a really key OPSEC habit is forcing links into new containers. Say you're deep in an investigation and you find a weird, suspicious link. You definitely don't just click it. You right-click and you select Open Link in New Container. This simple step ensures that even if that link has a nasty malicious tracker in it, it cannot associate that click with your main login sessions or your actual personal identity. Setting up your browser properly is step one here. The sources heavily recommend Mozilla Firefox because it's fantastic for managing these dedicated containers. But hey, if you prefer a Chromium-based browser, Brave is a stellar choice because it actually strips out all of Google's background tracking connections right out of the box. Pair either of those with a privacy add-on like uBlock Origin to block those intrusive tracking scripts, and boom, you've instantly hardened your first shield.
Moving right along, Section 4, Virtual Machines, the Hardware Shield.
But what if a really sophisticated threat manages to escape the browser entirely? What if you accidentally download a malicious file? That brings us to our second, much thicker layer of defense: hardware isolation. This is achieved through virtualization. A virtual machine, or VM, is exactly what it sounds like. It acts as a completely separate computer running software style inside your actual physical computer. Most importantly, a properly configured VM shares literally 0 files with your actual host operating system. This means you can investigate dangerous targets, download highly suspicious files in this securely isolated environment, and if the VM gets infected, your real computer stays perfectly safe. This right here is where VMs become an investigator's true superpower: snapshots and clones. A snapshot basically freezes a moment in time, so after a messy investigation, you just click a button and the VM instantly reverts back to a pristine, original state, wiping away any malware or trackers. Clones, on the other hand, let you create a completely new, perfectly isolated machine for every single target you research. That ensures no two cases ever cross-contaminate your precious evidence. Okay, on to our final layer, Section 5, VPNs and Workflow, focusing on network isolation. So we've locked down the browser with containers, and we've secured the hardware with virtual machines, but we still need to hide our physical location as our data travels across the public internet. This brings us to network isolation, and it's a super common beginner mistake to think you can just turn on a VPN and suddenly become invincible. So let's address this directly. Right now, are virtual private networks the ultimate silver bullet for perfect anonymity? The reality? No perfect solution exists. A VPN will not magically make you a ghost. Think about it. If you log into your personal bank account while using a VPN, the bank obviously still knows exactly who you are, right? What a VPN does do is act as a critical privacy tool. It routes your internet traffic through a secure, heavily encrypted tunnel to a distant server. This encrypts your data so nobody snooping on your local network can read it, and it spoofs your location so the website you're investigating sees the VPN's IP address, not your true home or office network. But, and this is a big but, when you're picking this layer of your shield, you have to pay really close attention to jurisdiction. Not all VPNs are created equal. The source material actually explicitly warns against using VPN providers based in the US, the UK, or Australia. Why? Because of really aggressive data retention laws and intelligence sharing agreements in those places. You want a provider that explicitly respects your privacy and keeps absolutely 0 logs of your activity. Now, let's bring this all together. A standard OSINT workflow has 5 main stages: identifying sources, harvesting data, processing findings, analyzing connections, and delivering the results. When you apply your new isolation tools across these stages, like using browser containers, running everything inside a clean virtual machine, and routing it all through a trusted VPN, you drastically reduce your risk profile, especially during that critical data harvesting phase. Your identity stays fully protected. All right, let's recap our core takeaways from this explainer today. Defensive security isn't some software you just buy and forget about. It's a daily, intentional practice of compartmentalization. Always assume websites are trying to fingerprint you. Build your nesting dolls of security. Isolate your accounts using browser containers, operate inside virtual machines to keep your evidence pristine, and always route your traffic through a trusted VPN. Maintain that continuous, ethical account hygiene. But I want to leave you with one final, kind of provocative thought. You can build the most impenetrable technical shield in the world with containers, VMs, and encrypted networks. But what happens if you have a momentary lapse in judgment? What if you accidentally log into your personal email while you're inside your highly secure anonymous virtual machine? Does human error instantly shatter that entire technological shield you just spent all this time building? I'm going to leave you with that to think about, because honestly, your OPSEC is only ever as strong as your daily habits. Thanks so much for learning with us today on this explainer, and we will catch you on the next one.